Hey everybody, this is Mr. McKee with Net 225. Today I'm going to be going over Packet Tracer 15.6.1, which is configure IP version 4 and IP version 6 static and dynamic routes. All right, looking on my workspace, I've got the topology up here. Notice two LANs down here in the bottom left. LAN 1, LAN 2. Notice the IP addresses, version 4 and version 6 addresses. Same thing over here. Alright, this is our corporate network. We have an edge router leaving our local area networks and going out over a WAN connection to our ISPs, ISP1 and ISP2 routers. Alright, just so you know, it doesn't really, when you're reading the instructions, it shows you this, but this is going to be our main route. Alright, out to the ISP and out to the server, and then our backup route is going to be right here. Alright, so we're going to give different administrative distances to these to make this our main one and this our backup. All right. So we have that. Notice /30 network here. So if it's a /30, more than likely it's a router-to-router connection. All right. So in this case, 10.10.10.0 is your network. You have a 1 and a .2 for your interfaces, and you have a .3 for your broadcast. And then down here, they didn't want to waste any IP addresses, so .4 is your network here, 5 and 6 are your interfaces, and then .7 would be your broadcast. And if we had another router, .7 would be the next network. Actually, 4, 5, 6, 7 would be our broadcast. .8 would be the next network. All right. Remember, all the networks are always even numbers. Broadcasts are always odd. So if you're off one, you can kind of figure that out if you say it incorrectly. All right. So there. Notice down here you have different CIDRs for LAN 1 and LAN 2. So that might come into play later on. Notice this is our main route. I just know that from looking through the packet tracer. This is our backup route. So in real life, this could go to like one ISP. This could go to another ISP. In case this link goes down, this link would be up. All right. In our case, ISP1, ISP2, going through an ISP network switch, and then over to a server. All right. Now notice though, this server, that's the actual static IP version 4, version 6 of this server. Everything else that you're shown is networks. All right. So we got all that. All right. Edge router has 4 interfaces. Let's look at our addressing table. All right, 2 serials going to our WAN connections in red. 2 straight through cables going to our gigabit interfaces out to our switches on our 2 LANs. ISP1 has a serial and a gigabit. All right, so WAN out here, it's the local area network in here, the gigabit. ISP2, kind of like the mirror of that one. You got a WAN connection over here with a serial, and you have a gigabit for your internal going over here to the server. So main route, and this is our backup route to server, customer server from our LANs. All right. So in this packet tracer summary activity, you will configure static, static, default, and floating static routes for both the IP version 4 and IP version 6 protocols. All right, we're going to be doing all this stuff in order. All right. In this activity, you will configure IP version 4 and IP version 6 default static and floating static routes. Notice the static routing approach that is used in this lab is used to assess your ability to configure different types of static routes only. This approach does not reflect networking best practices. So best practices would be first thing you do when you log into the router or the switch, enable configure terminal, host name, whatever, service password encryption, you know, doing all your basic setup stuff. All right, but they didn't make you do this for this activity because that would make it a lot longer. All right. So this is long enough, trust me. Just doing this stuff. All right, so part 1 is configure IP version 4 static and floating static default routes. The packet tracer network requires static routes to provide internet access to the internal LAN users through the ISPs. In addition, the ISP routers require static routes to reach the internal LANs. And part of this activity, you will configure a IP version 4 static default route and a floating default route to add redundancy to the network. All right. ISP1 is the main, ISP2 is the backup. All right. So let's go up here. All right. So step 1 is configure an IP version 4 static default route on edge router, which is up here, top left. Configure a directly connected IP version 4 floating. I'm sorry, I missed one. All right, on edge router, configure a directly connected IP version 4 default static route. The primary default route should be to router ISP1. So this is the default route. All right, I'm going that way. All right, so default route is going to be from here. All right, come on. All right, to this interface. So this interface is 0000. All right, I'm just going to go into, see if it's on here. All right, 0000 on the next router is 10.10.10.1. All right, /30. All right. The edge router, all right, let me make sure the edge router configure directly connected. All right. So by default, go out that interface, or that interface is our default. Notice our log messages, version, stuff like that. All right, enable. Notice there's no passwords or anything, but edge router has been named already as the router. All right. So our default route. So if it doesn't recognize where it's supposed to go, all right. And we're going from, let me make sure. All right. So if it doesn't know where it's going to go out this interface. All right. So any IP address it doesn't know, with any subnet it doesn't know. So 0.0.0.0 space 0.0.0.0. This is your next hop. All right. That's where it wants to go. And that's on serial 000, which is, let me hit enter. All right, which is right there. All right. So step 2, configure a IP version 4 static floating static default route. On edge router, configure a directly connected IP version 4 floating static default route. This default route should be through ISP2, which ISP2 is down there. All right, it should have an administrative distance of 5. And since we didn't specify an administrative distance, it's going to default to 1. All right, just so you know that. So this is going to be our backup. All right. And we can do the up arrow to bring that back in. All right. So our backup's going to be .5. I'm going to mouse over this. All right. .5 is 0001. All right. So any IP address I don't know, any subnet I don't know, go to this interface as a backup with administrator 5. The first one we didn't put anything, so that was just a 1 by default. All right. So there's our default static route. There's our backup static route, or I'm sorry, floating static default route. That's a mouthful. All right. So that's in there. All right, now we're going to do configure, or part 2, configure IPv6 static and floating static default routes. And as part of this activity, you will configure IPv6 static default and floating static default routes for IPv6. All right, and then the first thing, let's see. All right, right there. All right, on the edge router, configure the next hop static default route. This primary default route should be through router ISP1. All right. So .1 was the IPv4 address. The IPv6 address is 2001:1:1:1/20/64. All right. All right, let me just make sure that's right. Yep, that's good to go. All right, IPv6 route, and we're just saying everything, 2:/0. So I don't know this, I don't know this, I don't know this. All right, so that one right there. A:1:1. All right. So like that. All right, then our backup, before I even look at the instructions, I know it's going to ask for this backup route through 0001, which is DBA:2:1 A2. See, IPv6 addresses are hard to remember. All right, IP version, where's it at? That one right there. All right, so we can take off all this. DB8:A:2:1. Oh crap! Hang on a second. That's not gonna work. If you make a mess up like I just did, just put no IPv6. Whatever you just typed in, it'll take it out. All right, so I'm gonna go back. I'm gonna take this, and what I just did, the default one, which is that DB8:A:1:1, I just put in 2 default routes. That's not good, so I just did no IPv6 route to the second one. This 1:1 is our primary. This 2:1 is our floating route. All right, so on the end of that, we need to tell it administrator distance of 5. 1's the default. We didn't put it in there, so there's 5. All right, so that should be good. So we're right here. We did that. We did that. We did next hop for floating static route. Okay, route should be via router ISP2, administrative distance of 5. All right, right here. All right. So Part 3, in this lab you will configure static and flow static routers from the ISP routers to the internal LANs. Step 1, configure IPv4 static routes to the internal LANs. And we're going to be doing all these on ISP 1. Okay, so configure the next hop IPv4 static route to the LAN 1 network through edge router. So we got to do one from here that goes this way, that way. All right. So basically, go IP route, go here via this. All right. From there, and then from this, to this network via this WAN connection from here. Sorry. Coughed. All right. Okay, so we need to do, let me make sure I'm on the right router, which I wasn't. Let me go to router ISP1. Let's go in here, hit enter. I like going up and seeing the version. All right, version. I see there's crypto because it has K9 in it. All right, ISP1 enable. Whoops. All right, so configure terminal. Yes. Sorry. All right. So go to this network first. Let me just make sure. All right. So go to this network. So IP route 192.168.10.16. And what we got to make sure too, all right, \28. This is how I would do this. Don't use a calculator because you can't use a calculator on the exam. I want to insert a, where's the text box? Is that a text box? Place note. All right, so there's our note. Move this down here. All right, so \24 equals 255.255.0, and I'm just going to do the third octet or fourth octet after that. All right, 25 equals a dot to 128 \26 equals a dot 128, 192. I have it memorized. I got to think about it. 27 equals 128, 192, 224, 28, 128, 192, 224, 240. Next one, \29 equals dot 248 \30 equals dot 252 \31 equals dot 254 \32 equals dot 255. Need an equals sign there. All right, so what we need to know, we have all these different CIDRs. All right, so 24 is pretty standard, right? That's that \24 right there. That just means that the first 3 octets are used up as the host address, and we can only use the 4th octet for addressing our hosts. All right, so borrow bit, \25, all these will be 255 for the first 3 octets. The only thing that's going to change is the 4th octet. All right, so what we need to know is this network, the .16 network, is a \28. So we got to do 255.255.255.20 backslash 28 is at 240. All right. Okay, and then that's via this interface. Via 10.10.10.2, which is serial 0000 is .2. 10.10.10.2. Okay, so there's our static routes going to LAN 1 from ISP. So we're going this way. All right, next hop is right there. All right. So go to this network with this subnet via this interface, right? And that is what it said, right? Configure a directly connected IPv4. Where am I at? Or am I scrolling too far down? Oh, I'm not down far enough. All right. On ISP1, configure the next hop IPv4 static route to the LAN 1 through edge router. All right, so that's what I did. All right, and the next one's going to be for LAN 2. All right, so LAN 2 is right there. So we can reuse this. Let's do an up arrow. Let's actually, I hate doing that because I mess up. We know our CIDR 27 is different, and we know our network's different, right? So our network, instead of the .16, it's 192.168.11.32. All right, and then our CIDR, we know everything's 255.255.255 backslash 27 is right there. 224. 224. All right. Our next hop's the same because that's going from ISP1 to LAN 2 through the edge router. All right. Yes. So that's right. All right. So I wish I could scroll up a little bit, but whatever. Let's see. Alright, so on ISP1, configure a directly connected floating static route to LAN 1 through the ISP router 2, or through the ISP2 router. Alright. We can do that. Alright, so gigabit 00. Alright, 00 is 002. Alright. We're doing an IPv4 address. And I'm just going to take all this out. Alright. So we're going back here. Oops. We're going back to that interface with that subnet. We'll probably do this. Alright, so there's the correct network, there's the correct subnet. But the only thing different we're going to do is a 00, the 5. Yep. That looks right, yep. Alright, so that's done. Alright, so our on ISP1, configure the next hop IP version 4 static route to LAN 2. Alright, so LAN 2 is the 192.168.11.32. Alright, so all that's going to be the same. Make sure, let's see, IP route 11.32 /27, verify that's right, Alright, that's going to be using gigabit 005. Alright, that looks good. Alright, configure IP version 4 floating static routes to the internal LANs. On ISP1, configure a directly connected floating route to LAN 1 through the ISP2. No, that's what we just did. Alright. Yeah, I wish I could scroll down. I can't scroll down any farther. Alright. Let's see. On ISP1, configure a next hop IP version 6 route to LAN 1 through the edge router. Alright, so basically what we're going to do there, ISP1, go into this IP version 6 address. No, I wish I could highlight it by itself. And I can't. The bottom one. 2.0.1db8.110/64. Alright, go to that one. Alright, via this network. And this interface, which is 0000, which is the A1::2 address. Yes, A1::2. And it's a dot, what is that? :1.2. Okay. So IPv6 route 2001:db8. Now I'm not doing these uppercase like it shows, but it's fine. 10: alright, 64 via 2001. A1::2. Which is right here. Alright, that interface. VB8:A:1:2. Alright. I'm going to leave off the /64. Alright, so make sure, are we going to that network, right? IPv6 route, that network via this interface. Alright, so that should be good. Alright, now the next thing we're going to do, let's see. Alright, so in ISP1, configure the next hop IP version 6 static route to the LAN 2 through the edge router. Alright, so the only thing that's going to change there is the network. Alright. So all we should have to change is DB8:1:11. So this was our first one. That's our first static route from ISP1 through the edge router out to LAN 1. This one's going to be to LAN 2. And the only difference is that the 10 changed to 11. Alright, and it like that, so that's good. Alright. So let's see. On ISP1, configure the next hop IP version 6 floating static route to LAN 1 through the ISP2 router. Alright, so now it's going to be going this way, ISP1 to ISP2, and then to the edge router, then over to our LANs. Alright, so instead of that way, they're going this way up there. Okay. So let's see. So here's our first, we're still going to this route, IP version 6 route, we're still going to that network. The only difference is, change this out. Alright, so let's just make sure that's right. Alright, that's for our LAN 1. Alright, so instead of going this way to that next hop, we're going to go from here to this next hop. So that's gigabit 00 on ISP2. Alright, gigabit 00 is 2001:DB8:F:/F:/2 or /64. So let's go up here. It's this one right here. Alright, 200 DB8:F:/F:/2. Alright, so this is going to be our floating routes. Let's just make sure. Alright. So configure the next hop IP version 4 floating static route to LAN 1 through the ISP2 router. Alright, administrative distance of 5. Remember the default's 1, so the first ones are going to go first, but this is like a backup. Alright, 5. Alright, and like that. Now the next thing we're going to do is configure the next hop IP version 4 floating static route to LAN 2 through that same, basically the same path, just when it comes out of edge router, go to LAN 2. Alright, so only difference is going to be that the 10 goes to 11 for the network. So let's do that. All that's the same. Just going to change this 11 out for the network. Alright, let's make sure everything looks right. Alright, looks good. Alright, if your configuration has been completed correctly, you should be able to ping the web server from the host on LAN 1 and LAN 2. In addition, if the primary route link is down, connectivity between the LAN host and the web server, if the primary route link is down, connectivity between the host, the LAN host, and the web server should still exist. Yes, that is correct. So let's go to PCA. So let's see if I can ping the web server. When I say web server, that's not technically, that didn't have to be on the internet. And don't worry about that request timed out the first one. That was just doing an ARP translation. All right, so that works. And let's ping the IP version 6 address. FF:10. No, does that have to be a /64? No. FF:10. Oh, that's what I did wrong. 10. Alright. Ping 2001:DB8:F. Yeah, man, this is why IP version 6 addresses are way easier to make errors. 201:DB8 colon F colon F colon colon 10. Alright, double check it. Alright, still not working. Colon colon 10. It's not 64 though. Oh, yeah. Golly. How about that? Now that I typed it in correctly, it works. Imagine it. Alright, that's why I just love doing the IPv6 addresses. It's my favorite. Alright. So we're good there. I'm just going to assume that PCB works too. Alright, you guys can check that. Alright. So we are to right here. Alright, part 5. Configure host routes. Users on the corporate network frequently access a server that is owned by an important customer, and as part of the activity, you will configure static host routes to the server. Alright, one route will be the floating static route to support the redundant ISP connections. Alright. So we've done static routes from the ISPs over to here, but not from here over to the ISPs. Alright, so and this thing keeps scrolling down. Alright, so edge router. Alright. So on edge router, configure a IPv4 directly connected host route to the customer server. Okay. So statically to that server. All right, IPv4. All right, so let's do enable configure terminal. Alright, so static route, you're going to be doing it directly to the ISP itself, or IP itself. 10. And now here's the thing. If you do something just to itself, that's the reason you use a \32. Only that IP address is valid. Alright, down here, that would be 255.255.255.255. Alright. And if you do it for IPv6, it'll be a \128, which is not really the same as, but that's just like all Fs across the board for IPv6 address. Everything's at the highest number it can go to. All right, so 255.255.255.255. All right, that's why that looks weird, but that just means just that specific static address is the only one that's valid. All right. And we want to go out, let's see, directly connected to the host server. All right, so serial 0, 0, 0. All right. On the edge, I spelled edge wrong. Edge router configure IPv4 directly connected floating host route to the customer server. So I would assume, let's see. All right. Serial 001. All right. So same thing, same IP address, same default gateway with all 255s, except for the one which would change. Oh, you know what I didn't do, right? So I messed that up, didn't put my administrator distance of 5. So I'm going to go back here and I'm going to put in no. Same command I just put in. Alright, that just took out the command. I'm going to go back in there. I'm going to put, well, let me take off no first. Alright, take off no, and then put my administrative distance of 5. Alright, that looks way better. Okay, and then part 5, step 2, on the edge router, configure an IPv6 next hop host route to the customer server through ISP1 router. So that's going to be our IP address. IPv6 route. Okay, so 2001 DB8 FF : 10. All right, now we're going to do a /128 because we're saying only this specific IP address is valid. So that's the same thing as doing all 255s for a IPv4 address, or all Fs for a IPv6 address, since IPv6 is using hexadecimal. So 128. So pretty much everything's a network. Everything's used on the network except for the actual IP address that you're referring to. In this case, I'm referring to this IP address. All right. So super restrictive. All right. So, and let me make sure. Okay. So I'm saying that route. Okay. And let's see. Configure the IPv6 next hop host route to the customer service through router 1. And that would be 0000, which would be right there, 2001. That right there. B8. I have to make sure I don't type these in incorrectly. All right, that. All right, that. All right, :1, 2001, :DB8, :A, :1, :1. All right, so that's good. All right, so A1. All right, so our next one will be our floating route. So if we do up arrow, still going to this, still doing our route, still going to this static IP address with that /128. This will just change to our next hop, which would be the next hop is right here, 0001 DB8A2 : 1. So serial 001. All right. DB8A : 2001. Okay. So the only thing that changes is this right here. The 2 after the A. So 2001 : DB8 : A : 2 : 1. All right, that right there should be good. What I'm almost always forget is it has to be administrative distance of 5. All right, so make sure you put that on there. If not, do like I do, up arrow, just arrow over to the left, put in no. All right, I got caps lock on, just put on no. Do that, it'll take it out. All right, You can do backspace, you just can't do delete. So I'm not going to touch that since I entered it correctly. So the big thing is, before you even start on this thing, plan out what you're going to need, what kind of information you need. The big thing is to know this. And I would say for the CCNA exam, I haven't taken the version 7 yet. I took one 2 years ago. This is like a big part of it. Knowing subnetting for Class C addresses, memorizing that. I can just borrow a bit, 128. Because if your magic number is 256, so that 255 is the 256th number in each octet. All right, that's the last number you can use because 0 is used as the very first number in binary. All right, so if you say 256, half of that, so you basically \25, you're splitting a regular Class C address into 2 subnets. All right, so half of 256 is 128, and then the reason from there you get to 192 is if you go 128, split that in 2. All right, you already have 128, and then add 64 to that. That gives you 192, and then half of 64, all right, is 32. So 192 plus 32 is 224. Half of 32 is 16. 224 plus 16 is 40. Half of 16 is 8. 240 plus 8 was 248. Half of 8 is 4. 248, 252. Half of 4 is 2. 252 to 254. And then half of that, 255. That's how they did it. It's not real. It makes sense once it clicks, but until it clicks, it's kind of rough. All right, so let's see. What else do we got here? And I think that's it. Man, it only took 47 minutes, and I redid this video a couple times because I kept messing up. But I think you guys got it. Everything's working. You can try to ping, but we know it's working, so that's good. All right, so basically, look, we learned all that stuff. All right. Yeah. And talking about subnetting too, that's something you just have to go over, and it's great going online and finding the subnet calculators, but that's not going to help you on the exam. All right, they do give you some dry erase marker, and that's the first thing I write down is what all the variable length subnetting is. All right, so I can remember it and don't have to mess it up. And also, all your networks, they start out with even numbers, and all your broadcasts are odd numbers. So if all your networks are even numbers, your first usable host addresses are always odd numbers, and your last usable host addresses are even numbers, because your last usable host address is one number before your broadcast. All right. But anyways, it's good to go over that because that's takes a while to remember, and then if you don't do it for a while, you'll forget it. All right, but that's it. Thanks for watching. See you later.